Right. So, good evening. So, I'm just doing some pep talk by the time that you all settle up. So, our job in this chapter is to study about forces. And when we study forces, one of the part which is of most importance for higher level, when you go to say, if you stay in Cambridge in AS level and all, it will be mechanics and we'll get to know something called NLMs. NLMs are Newton's laws of motion, classical mechanical problems. But for that, the concept of force should be good. And in Cambridge Newton's law, unfortunately, they are all in half of pages. In that way, you can only memorize Newton's law, but you will not understand what is Newton's law. Okay. Before going to the Newton's laws part, we have something where we have to discuss about balanced forces, unbalanced forces. So let us have a quick look. Now, our knowledge of force is important to understand Newton's first law, second law, third law, as I told you. But however, the outcome of Newton's laws also tell us more about force. So let's take up spring force part is clear to everybody, F equal to kx, where you will be asked to find out the spring constant and all. So now we get into something called the nature of forces, where we talk about balanced versus unbalanced forces. Now this is mathematical and bit of logic is also there. So dimag khol ke suniye, balanced and unbalanced forces, how to understand, right? Now let's say I have got a sphere or any body. This is a sphere or any body, and it is acted upon by a force. इसमें एक force लगाते हैं, ठीक है? So today we'll use our drafter. ऐसे सोचते हैं ना, इसको कब काम में लगाएंगे? आज काम में लगेगा. So let's acted upon by a force, and I have put a force out here, and let's say this force is 2 Newton. Let's just understand 2 Newton, right? Now, whenever you see a system with a force acting on it, the first thing that you should try and understand is to find out what is the line of action of this force. Now, the line of action of this force is along this line. Which essay? This is the line of action of the force, correct? Now, if you have another force which is acting from here and right on the opposite side, say this force is another 2 Newton. Now, forces are vector quantities. Vectors need to be specified by their magnitude as well as with their direction. So अगर हम इसे properly दिखाएं तो हम दिखाएंगे this is force F1 and a vector is always shown with an arrow on the top. This arrow does not signify direction. This arrow only tells you that it's a vector quantity. Correct? Any vector quantities, like say later on you will study about something called torque, angular momentum, all these things will have an arrow. Arrow shows means they are vector quantities. They need both magnitude and direction. So I'll say my F1 is 2 Newton. मैंने इसको east लिख दिया. Make sense? And I say that I have got another vector which is F2 as a vector, and this vector is 2 Newton west. बोलो बच्चा, ये दोनों चीज समझ में आया? 2 Newton east and 2 Newton west. However, these two forces are acting along the same line of action. In such a case, you won't see any impact on this body. We won't see any impact on this body. This is called a balanced system of forces. इसको क्या बोलते हैं? Balanced forces. What is the outcome of the balanced force? Sir, the outcome of the balanced force tells me that system continues to be in static equilibrium. There are two concepts here. Static equilibrium. Equilibrium means what? Net of the forces acting on the body is equal to 0. इसमें अगर हम equilibrium की बात करें, what do you understand by equilibrium? So we will say that net force is 0, and we'll also say something called net torque acting on the body is 0. Now what is torque? Don't break your head right now, we'll come to it. Net torque acting on the body is 0. Okay? This is a condition for equilibrium. Equilibrium means we put Sahasra on a table and there are a lot of forces acting on you. Somebody is pulling you by hand, somebody by hair, somebody by pushing you, but somehow you are at that position itself. Then we say that you are under equilibrium. Means your net force acting on you is 0. That does not mean you don't feel any pain because people are pulling you by hand and hair and all. But the net force is 0. Net torque is also 0. अब एक बात समझेंगे कि बैलेंस फोर्सेस और इक्विलिब्रियम में डिफरेंस क्या है. ठीक है, एक और क्राइटेरिया लेते हैं. जरा इस क्राइटेरिया को देखिए तो बच्चा लोग, let's say I have a body which is in the shape of a cuboid or a rectangle. Oh, it doesn't go far. Okay, let's say this is this much. This is my body. Clear? बच्चा समझ में आया? and I have it acting upon by a force, and let's see the line of action of this force is this way, and I have a line of action here. Okay. There are two forces acting on it. This is 1 Newton east and this is 1 Newton west. Okay. Please ask me questions out here because यहाँ पे बहुत सारे सवाल आपके मन में आएंगे, पूछिएगा. Did you understand the first criteria? The first criteria were two equal and opposite forces acting along the same line of action. Equal and opposite forces, are they equal and opposite? Yes. Are they acting on the same line of force? No. ऐसे सिस्टम को भी हम बोलेंगे balance force. This is a balance force because the net force in this system is still equal to 0. Why is the net force equal to 0? If I say that my F1 force is equal to this and this is equal to my F2 force, then I can very well say that F1 as a vector is equal to opposite of negative of F2. अच्छा, अब negative बहुत सारा चीज हम सीखेंगे, negative का मतलब क्या होता है. Okay. Cambridge here deals the things at a very, very narrow level. If you read the book, maybe you will be able to solve a problem of the book, but not more problems. Let us first understand now, leave force and go to a little bit of vectors. Okay, leave the diagram here and come back and understand something called vectors. The best to understand vectors are using force, right? So now look at me. Suppose I denote this as a vector F. This is a vector F. Look at me as I am drawing it, right? And this is F, which is equal to say 2 Newton. 2 Newton है इसका. What does a vector have? A vector has got a magnitude and a vector has also got a direction. Let's talk about magnitude. The length with which we draw the vector is proportional to the magnitude. So if I am supposed to show a 1 Newton force here, it should be exactly half of this arrow. तभी तो समझ में आएगा. 4 न्यूटन दिखाना है तो इसका डबल बनाएंगे हम लोग. समझ में आ रहा है बच्चा? I make another vector which is like this, and I call this as F1. I call this as F2, and I say that the magnitude of this is also 2 Newton. Look at me. पहले देख ध्रुव, नया चीज है. दोनों वेक्टर का मैग्नीट्यूड सेम है, and I use that special device to draw it just to ensure that they are parallel. That means the direction is also same. In such a case, we will always say F1 as a vector is equal to F2 as a vector. Two vectors are equal. IFF I am writing. This is a word we use in mathematics. IFF means if and only if. Whatever condition I say, both have to be honored. If and only if magnitude of the vector F1 is equal to magnitude of the vector F2. Children, this means absolute value, magnitude. And direction of F1 should be equal to direction of F2. ऐसे केस में ही आप बोल सकते हो कि दोनों वेक्टर इक्वल है. Did you understand? Two vectors, no matter where they are drawn in this universe. बात समझ में आई? कहां ड्रॉ किया उससे कोई मतलब नहीं. अच्छा चलो, तुम्हें कंफ्यूज करने के लिए मैं यहां पे एक और वेक्टर ड्रॉ करता हूं. ये देखो तो, ऐसा एक और वेक्टर ड्रॉ कर दिया F3, और इसकी वैल्यू भी मैंने बोली दिस इज 2 न्यूटन. आर द थ्री वेक्टर्स इक्वल? यस. Their magnitude is same, their direction is same. Sir, how do you say their direction is same? They are all parallel to each other. And make one horizontal out here. If this is 30 degree, this is also 30 degree, this is also 30 degree. Yes, sir. These two lines means absolute value. Very good. In mathematics, we say something called absolute value. Absolute value. अच्छा children, be little bit open-minded. Whether you are a CBSE, ICSE, IGCSE, state board, whatever, maths is maths. कुछ चीजें ज्यादा सीखोगे तो आपको कुछ हानि नहीं पहुंचाएगा. सीखो. Absolute value का दूसरा नाम होता है मॉड्यूलस. Modulus. And when we write, say, x, we read it as mod x, or we read it as एब्सोल्यूट वैल्यू ऑफ x. आपकी मर्जी. हम लोग ज्यादातर mod x पढ़ते हैं. इसकी यूज क्या है? If I give you a number 5, then the absolute value of 5 is 5. If I give you a number -5, then the absolute value is also 5. Where do we use it? Now, where do we use it? In physics. Let's say this is Dhruv, है ना? And this is his reference point origin. He walks towards the right. I said he walks 2 meters right. And his displacement on this side will be 2 meters left. मैं इन दोनों को कैसे quantify करूं? In physics, how do I quantify? I say that here his S1 is equal to plus 2 meter and here his S2 equal to minus 2 meter. We are using a sign convention. Minus does not mean my boy is walking less. My boy is walking the same distance but opposite to the reference point. Do you understand? In such a case, but did he walk anything called -2? No, he walked 2 meters only. So we would say that the absolute value of the displacement S1 will be equal to 2 meters and the absolute value of S2 will also be 2 meters. And displacements are vector quantities. Don't you agree? However, as a vector, if I want to show, I will always say that S2 is negative of S1, or you can say S1 is negative of S2, because the two vectors might be equal in their magnitude, but they are 180-degree opposite in their orientation. ये माइनस का मतलब वेक्टर्स में nothing that you are inferior. 5 and -2. In mathematics, -2 is a smaller quantity. In physics, minus is used to show you the direction. It does not mean this day. He has, उसको जितना मेहनत इधर हुआ उतना मेहनत इधर हुआ होगा. Have you understood? So see, because these depth if we don't cover, that's why look at here. If I am calling this force F1 2 Newton east, generally we take east as positive because we are going on the x-axis. So west will be taken as negative. तो मैं इन दोनों forces में, बच्चा मुझे बताओ, इन दोनों forces में can I write, now since you know how to read modulus, can I write modulus of F1 is equal to modulus of F2? Can I write this or not? Yes, because both the forces are 2 Newton in their magnitude, but they are acting in opposite direction. So when I represent them as vectors, I will write F1 is negative of vector F2. Have you understood? And sir, if you wanted to write it as equal to F2, then that force also should be in this direction. So like here, in these cases, I will write F1 as a vector is same as F2 as a vector, is same as F3 as a vector. Got it? And what is it? I will write 2 Newton 30-degree northeast. 2 newtons 30-degree northeast. Sir, what do you mean by that 30-degree northeast? Beta, 30-degree northeast means, say this angle is 30-degree and this is in northeast direction. All the vectors are 2 Newton 30-degree northeast. So this satisfies me in a vector that their magnitude as well as their direction is same. Has this thing entered your head or not? Because if it has not entered, I will make it enter again. But we won't proceed without this getting registered in your head. समझ में आया? And if you have understood this, then one more thing and then I'll allow you to write. Once you have found that two vectors are equal, right, that this vector is equal to this vector, you have a right to pull down the vector anywhere you want. This vector is here. I can pull down this vector here also. I can pull it here. But you should not change the direction and magnitude. So say this was some 5 centimeters in our graphical drawing. I will draw it that same parallel. कहीं भी यहाँ पे भी ले आ सकता हूँ. मेरी मर्जी. यहाँ पे ले आया. F3 को मैं यहाँ ले आया. ऐसे प्रोसेस को हायर मैथमेटिक्स में हम बोलते हैं पैरेलल ट्रांसलेशन of a vector. You are allowed to do this. A vector can be parallelly translated anywhere as long as you don't cherify its direction and its magnitude, which anyway you will not do. Do you understand? So a force acting, now you will say, but sir, does this not change the whole story? How? Sir, the arrow was acting on the bonnet of the car. The arrow was acting on the bonnet of the car. You are parallelly pulling it to the roof of the car. Say a force, let's say this is my force. This force is acting right now on the middle of the table. Parallel translation allows me to bring it here parallelly. You mean to say, sir, यहाँ का दर्द यहाँ ले आया आप? न्यूटोनियन स्टडी में सारे बॉडीज को पार्टिकल नेचर में देखा जाता है, पॉइंट ऑब्जेक्ट. So it doesn't matter whether you are hitting it here. When you do the analysis of a car, we don't analyze the car as a whole. The car is thought to be a point object. A point को यहाँ से लगे और वहां से लगे क्या फर्क पड़ता है? You get it? So have you understood parallel translation? How vector language we write? In vectors we are supposed to write. Now again coming back to our initial discussion, we had two forces which were represented by vectors which were just equal and opposite. Here also they are represented by vectors which are equal and opposite. Don't you think that this criteria is valid out here? Yes, equal and opposite, because I am allowed to do translation, equal and opposite. यहाँ पे भी F1 is equal to minus F2, पर इन दोनों में एक फर्क है. The difference is this will be called as a balanced system of forces. Sir, is this not balanced? This is balanced, plus this will be causing equilibrium. Here you won't disturb it, but in this case, if you take a screw and you screw or nail this thing out here, इसको screw कर दो अभी यहाँ पे, और ऐसे forces दो तो ये rotate नहीं हो जाएगा, ये rotate हो जाएगा. ये ऐसे देखो, ऐसे घुमाएंगे तो ये ऐसे twist हो जाएगा. ये this thing will twist. You take a screw and put it here, and you just do it like this, it will twist. So are you in equilibrium? No. Your stature has got disturbed. Equilibrium means there should not be any force acting on you and there should not be any torque. And I told you, please hold torque. I have not explained. Now comes the moment to understand torque. A torque is an influence which will cause twisting in you. Like the clock's hand. टिक 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 घूम रहा है ना, टॉर्क से हमेशा बेटा रोटेशन होगा. Any pivot joint will have a torque acting on it. Look at your hand. This is a pivot joint. ये घूमता है ना torque. One of the best examples. गाड़ी देखो तो इधर देखो नहीं देखोगे फिजिक्स. गाड़ी का स्टीयरिंग. How do we drive the car? ये हाथ नीचे खींचता है तो ये हाथ ऊपर दबा रहा है. Look, this is driving, and the car is pivoted right on the steering. You see, where is the maker's name is there? Honda, Creta, whatever is there, Hyundai. It will be written there. It's pivoted right there, and the steering rotates. No matter you are giving equal forces, but the line of action is not same. In higher mechanics, such type of a forces is known as a couple. When you have two equal and opposite forces which are separated by a distance, you make a couple. Let us see where all we see a couple. Have you seen the municipality road? On roads you will see those circular plates which can be opened because they have got sewage lines inside. Have you seen how the municipality guy opens it? He uses a T type of a wrench. The wrench will have a bar which will be on the nut and a T, and he'll rotate it like this. Equal and opposite forces will always constitute a couple, and a couple will rotate. Go back to those old village type of taps, the brass taps that we had. How do you open the tap? If your thumb pushes the knob this side, the index finger pushes it this side. Couple. समझ में आ रहा है? यहां भी बैलेंस फोर्सेस है, पर इशू क्या है? इक्विलिब्रियम नहीं है. इक्विलिब्रियम नहीं है. इस बार इसको मैकेनिक्स समझना है तो you should understand from this level. It's not about half page of Newton's law of motion. I mean, in that way you will never understand, you will never fall in love with the topic at all. So tell me now one thing. Have you understood what is balance forces? Balance forces on the same line of action creates a equilibrium. In an equilibrium, net force will be zero, net torque will be zero. Torques are created only when you get difference between the pivot point and the point of application. Look at this scale. I am screwing the scale out here, okay? And where am I applying the force? I am applying the force here. Is there a distance between the point of application and the pivot? Yes, this is the distance. This we will read in our chapter called moment arms, and that's there in our syllabus. This is called the moment arm, and then you see force देने से ये rotate हो जाता है ऐसे देखो. Momentum, पढ़ेंगे उसको. Clockwise movement, anti-clockwise movement, we'll study that. If your point of if it is a pivoted system, and if, even you look at the sabji wala, where has he pivoted? He has pivoted here. हाँ, एक मिनट बेटा, sabji wala has pivoted here. If you apply load on this side, there is a difference. If the load was applied here, nothing will happen. If the load is applied here, toing, toing, seesaw. Seesaw is the best example. Center में pivot करके, if you make the बच्चा sit on the pivot, seesaw will not move. Clear हुआ? Yes बच्चों, बोलो. Ashmita, go ahead.
Yes, sir. Sir, I still can understand equilibrium.
Okay, equilibrium means there should not be any net force acting on you and net torque acting on you. Equilibrium are of two types. अभी हम उस equilibrium के बारे में भी बात करेंगे. Equilibrium means how you were, you remain the way you are.
Okay.
Let's say psychologically, Ashmita is a big time liar, let's say, and we are doing her interrogation. Okay, psychological interrogation, right? In have you seen the movie Drishyam? देखा है? So it's like that movie Drishyam. Your interrogation is going on, and you are lying and lying in such a manner. There is no change on her face, no matter how much cross interrogation we are doing. She is in equilibrium. जैसा था वैसा ही है. परिस्थितियां, circumstances are changing, but I am not changing. This fellow is right now being acted upon by two forces. The shape may change if you break its rigidity. Suppose this ball is a big iron ball and you are applying 2 Newton force. You don't expect the shape to change. You feel as if the body is still at the stature of rest. But इसको force feel नहीं हो रहा है क्या? बिल्कुल feel हो रहा है. इसको हम कहते हैं equilibrium. This is called static equilibrium. Right now, if both of these two children are sitting on the stool or the chairs, the table stool you all are sitting, you are in static equilibrium because the weight applied by you is equal to the reaction given by the stool. If the stool was not made of good quality and the reaction was less, you by now would have fallen down. So if I replace you and I bring one elephant from Hyderabad Zoo and I make him sit on my table right now, will it be in the equilibrium? No. Because one of the force is more, the other force is not able to balance it. Along the same line of action. Other children who are sitting right there, look at Kirtan, he is right now sitting on a wheel-based chair, computer chair which has got wheel. So how does the chair look like? It will have a cross 4 platform. After that there will be the gas lift piston. So is exactly his body mass is on that one particular rod, that piston, जिसको ऐसे करने से उठ जाता है chair नीचे करने से. If Kirtan would have been very heavy and the chair was designed for kindergarten students, will the piston be able to hold him? No, he is not in equilibrium. वो गिर जाता. समझ में आया?
Yes.
ये है static equilibrium. तो balance forces समझ में आया आपको पहले. We'll come back to equilibrium also. First understand balance. Diagram दिखाएगा आपको. In your ways, if they ask you, is the system of forces balanced? My dear student, only look at the direction of the forces and their value. If they say is it equilibrium, then please look at the line of action. This is equilibrium. देखो अस्मिता, ये हिलेगा नहीं, ये हिल जाएगा, तो ये equilibrium में नहीं है.
Okay, because it's acting on different.
हाँ, because ये rotate कर जाएगा ना. Just do with me ना. You put your hand below your shin. करो मेरे साथ तो मजा आएगा. करो हाँ shin and this hand on your head. उल्टा हैंड ऑन दिस साइड. आप दोनों को दोनों साइड खींचो तो आपका मुंडी घूम नहीं जा रहा है. हाँ, तो एंड नाउ डू दिस थिंग, पुश फ्रॉम दिस साइड एंड पुश फ्रॉम दिस साइड. आराम लगता है, सर हिलता नहीं है ऐसी. यस, दिस इज स्टैटिक इक्विलिब्रियम. But in both cases you applied equal forces, so they were a balanced system of forces. This causes static equilibrium, this causes a rotation.
Okay.
Understood?
Yes, sir. Thank you.
Okay, now we will little bit divert again from static equilibrium. We'll see dynamic equilibrium क्या होता है, ये भी देखते हैं. ठीक है, चलो ये मिटाओ, ये क्लियर हुआ. आइए इसके बाद बैलेंस अनबैलेंस में क्लास 11 तक कोई क्वेश्चन नहीं रहेगा आपका और यू विल बी परफेक्टो. Okay, let's see one more criteria. So just because Asmita has cherified, so we need to understand equilibrium. You will later study chemical equations in equilibrium. This is there in our grade 9 and 10. ammonia. Remember the word ammonia. We will come to equilibrium again in chemistry. Okay, equilibrium. Equilibrium can be of two types: static and dynamic. In static, body, BI and AI. BI means before incident. Before we asked Ashmita to press her head on both sides. What is the body? Her head. What is the incident? She pressing her head on both sides. Before incident and after incident, body will always be in rest. Do you understand? This is called static equilibrium. In dynamic equilibrium, our body before incident and after incident was always in uniform motion and will remain in uniform motion. कैसे होता है जरा देखिए. This is our car. Our car is going at a speed of 50 km per hour. Uniform and straight line. और straight line में जा रहा है. Is it uniform motion? Yes, uniform motion. In uniform motion, there should not be any acceleration. There is no acceleration. अब suppose मान लो यहां से we are talking about say Hindu mythology discussions. This is ध्रुव देवता. ये ध्रुव देवता आ गया और वो यहां से क्या करता है, हवा मारना शुरू कर देता है गाड़ी के पीछे. ठीक है, कितना हवा मार रहा है सर? 2 न्यूटन हवा मार रहा है ईस्ट में. एंड फ्रॉम हियर आवर कीर्तन देवता ऑल्सो कम्स, वो भी हवा मारना शुरू कर दिया, 2 न्यूटन. What is the condition of the car? Car still remains to go at 50 kilometers per hour only. Are additional forces acting on it? Yes. Are they balanced? Yes. Is there a change in the motion of the car? No. Car is in dynamic equilibrium. Have you understood? One more good example. इसमें आपको और मजा आ जाएगा. So we have gone to Ashmita's house and she is doing one experiment. This is her bathroom tap and the tap is filling up a bucket. ठीक है ना? The tap is filling up a bucket and say the bucket is filled up till this level. This level of the bucket is H, right? And this is the control valve of the tap. What our friend Ashmita does here, she does some interesting observation. क्या करती है? वो ये bucket में एक hole create कर देती है. She creates a hole in the bucket. As a result, what happens? Water starts leaking from the bucket, right? But somehow she has maintained, she has done a lot of experiments and she has designed the hole and the speed in such a manner that the height of the water always remains constant. क्या beautiful है, देखो पानी को इस तरह से एडजस्ट किया और होल को इस तरह से बड़ा किया है, जितना पानी निकल रहा है उतना ही पानी गिर रहा है. आर यू अंडरस्टैंडिंग? आप जाते हैं ना तो टेम्पल्स एंड ऑल दिस प्लेसेस, यू सी लॉट ऑफ फाउंटेन, इधर पानी गिर रहा है. Whatever water is falling is the same water being pulled up. Otherwise, the whole fountain pond should be over. This is a classic case of dynamic equilibrium. Where now tell me what is changing, sir? The water sample every time is changing, but the height of the water anytime you go and see it is 5 meter. Let us take one more example. Let us look at the swimming pool of Pebble City. How many people we have? Sir, we are having 2,538 houses. On a peak summer, everyone wants to go to the swimming pool and everyone does go to the swimming pool. Now ask a question to yourself. Does everyone take, okay, they might not swim, but everyone comes back home taking a dip. कैसे possible होता है? Swimming pool is a very nice example of dynamic equilibrium. Initially, you will see one common thing in a swimming pool. This is the swimming pool. You will see people inside the pool. There are people inside. You will see some people here who are just having a shower to get ready, and you will see some people here who are just wearing their clothes. At a time, there is a constant number of people in the pool always. यहां से लोग शावर लेके अंदर घुस रहे हैं और यहां से लोग उठ के फिर कपड़े पहन के जा रहे हैं. हमें ऐसा लगता है कि पूल में तो उतना भीड़ नहीं है. Yes, the pool has got, if the pool can hold say 22 people in a sleeping manner, there are 22 people. But these 22 people are constantly changing. Dynamic equilibrium. समझ में आया? This is classic case of dynamic. Have you understood now? So in our case of whenever we talk about balanced forces, balanced forces are those forces which are acting exactly in equal and in opposite direction. So with that in mind, let us see some scenarios. Let's say we have a body out here and the body is being acted upon by a force of 7 Newton and the body is being acted upon here by a force of say 3 Newton. My question is this system of forces balanced? No, this system of forces is not balanced. Such a system we will be calling as unbalanced forces. Unbalanced forces. And this system can now be replicated as 4 Newton of one net force. Do you understand this? It is equivalent that the body is being acted upon by a 4 Newton force. So whenever you will have unbalanced forces, you will give rise to a net force criteria. समझ में आया? Right. Now we as engineers and scientists all over the world, let's say there is a body and this body is acted upon by a force here, another force on this side, another force on this side, another force from this side. So obviously you will first of all looking at it, you will say it's an unbalanced system of forces, देख के लग रहा है, ठीक है ना? Then the question arises, what is the net force acting on the body? We should, because here net force is very easy, both are acting in straight line, so we just said 4 Newton. यहाँ कैसे बोलेंगे? यहाँ भी तो बोलना आना चाहिए. What is the net force? Are you understanding what is my problem now? Here net force निकालना आसान है, कोई भी एक. सर मेरे को ना इस साइड में मम्मी पुल कर रहा है 5 न्यूटन, डैडी पुल कर रहा है 2 न्यूटन, तो मैं मम्मी की तरफ ही जाऊंगा ना 3 न्यूटन से. इट्स इक्विवेलेंट टू दैट. बट सर इधर से एक बच्चा पुल कर रहा है, इधर से पुल कर रहा है, एक टांग पुल कर रहा है, एक उधर पुल कर रहा है, आप किधर जाऊं? वेयर डू आई गो नाउ? ऐसे चीज को जानने के लिए वी हैव टू अंडरस्टैंड एंड लर्न समथिंग कॉल्ड रिजल्टेंट ऑफ वेक्टर. Because force is a vector, resultant. When many vectors, say vector F1, vector F2, and then vector F3, and then vector F4, all are acting simultaneously, as engineers, we would like to understand, I don't know all these things. Sir, morning I spend 2 rupees on dosa, 3 rupees on idli, evening 4 rupees on detergent. What is the net expense at the end of the day? What is that one force that is acting on that body? Please tell me. And when you are asking that one net force, you are asking a vector. So you are asking magnitude as well as direction. This one net force, F net, is given by the vector addition of F1 plus F2 plus F3 plus dot 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 whatever it may be, Fn. N number of forces, but this addition is vector addition. That is what we are going to learn now, resultant. This is not algebraic addition. Algebraic addition में 3 plus 4 करने से कितना होता है बोलो? What is 3 plus 4? 7. In vector you will see 3 plus 4 if we add we get 5. हाँ, root resultant आएगा इसमें, ठीक है ना? ऐसा vector addition is not same as algebraic addition. So this is the vector addition. Vector addition means after all the forces impact of each force individually was studied, we conclude that rather than so many people pulling this particular ball, let one person come and pull the ball with an F net. This is what we are going to study now, how to decode. And you are going to study very, very easy resolutions. And I tell you children, they are very, very interesting. Are we ready? When more than one system of vectors, it is actually vector resolution, but since you are studying only force, so you call it as force resolution. And force is also a vector. Tomorrow when you go to higher classes, instead of vector, if it is acceleration, the rule remains the same. If it is momentum, rule remains the same. If it is torque, rule remains the same. Because everything is a vector. And you are learning vector addition. Though your book says force resolution, we will learn as vector addition. उसके बाद वो force हो कोई हो हमें कोई मतलब नहीं. Is the storyline clear so far? What did we study? Balanced forces, unbalanced forces, little bit about static equilibrium, little bit dynamic equilibrium, and also got a little bit of idea about torque. Torque comes into effect whenever there is a rotation, and rotation will happen whenever there is something pivoted or clamped and the force is applied at a distance from the clamping, तभी चीज घूम जाता है. Our head is pivoted at the neck. And earlier days sir used to नहीं पढ़ते हो तो देखो सर घूमता है. ये this much is the difference. I am pivoted here. This much is the difference. Here the force is applied. नहीं पढ़ते हो हो गया है ना. अभी वो नहीं कर रहे करके, हाँ तुमने जो अभी एग्जांपल किया उसमें भी देखो ये है, ये डिस्टेंस है, दिस इज पिवट, दिस इज, हाँ ठीक है. चले रेजोल्यूशन देखने के लिए आ जाओ. हाउ टू सी वेक्टर रेजोल्यूशन. सो वेक्टर रेजोल्यूशन मीन्स in smart language we are trying to do something called vector addition. Hey, this girl Sahasra, you have not seen Drishyam? It's originally a Malayali movie, and in Bollywood also this movie is available. It's such a nice movie, please see, but don't see part 2 if you have not seen part 1. First see part 1, then see part 2. You love it अगर आपको सस्पेंस पसंद है तो. Okay, both are available on television. Okay, vector addition. Vector addition के 3 रूल होते हैं. The first one is a very cutie rule called head tail method. And if you know this, you can add any vector. Acha sir, why are you teaching it? In physics we will be seeing a little portion of it, but there is vector algebra for you in mathematics. अगर यहाँ ये सीख लिया, वहां you will be एकदम running like anything. ठीक है. Head tail method. दूसरे वाले को हम कहते हैं the parallelogram law of addition. Parallelogram law of addition. And third is called the triangle law. Triangle law is a part of parallelogram law. Nobody studies it in detail because this one is the most robust. ये सबका आंसर दे देगा. ये थोड़ा क्यूटी है. ठीक है. This is cutie. This is parallelogram law of addition and triangle law. Triangle law is an extension of parallelogram, but all children are supposed to know, irrespective of your board, is parallelogram law. But we will first see what is head-tail method. In order to understand head-tail method, okay, what we are going to learn now is head-tail. Head-tail method. Head-tail method of vector addition. यहाँ मतलब गाना पड़ेगा, फिर आपको याद हो जाएगा. Let's take a vector. Let's take a vector, and this is a vector. A vector is represented by an arrow. So this is known as our head, and this is known as our tail. Head points to the direction where the vector is subjected to. Tail shows where the vector is coming from. And length of the vector should be proportional. When you are drawing it on graph book, length of the vector should be proportional to the quantity you are trying to specify. If 5 Newton is shown by 5 centimeter, 10 Newton should be shown by 10 centimeter and 15 Newton should be shown by 15 centimeter. देख के लगना चाहिए ये उसका छोटा भाई है. इतना क्लियर हो गया? Now we are going to add 2 vectors. Okay. Let's say I have one vector out here. This is say vector A. A vector is shown like this, and I have one more vector out here, and this is B vector. Somebody tells me find the addition of A and B. ये हटा दिया अभी. ठीक है. Find the addition of A and B. So I am supposed to do vector A plus vector B. Now you could say, sir, what if I had written B plus A? Well, doesn't make any difference. Vector addition is commutative. You did this before? We'll do this because we have to know. अभी आ गया बहुतों को, many not joined. I said no, we have to cover it. So A plus B and B plus A is all same. So how do you add a vector? Let's go by A plus B. So we are adding A to B, right? So on a nice sheet, we can take B vector. Vector translation is allowed. So I just take B vector. This is my B vector, same as I brought it. Parallelly, I can bring it. In fact, there is something available in the market called a roller scale. Roller scale. It is available in Amazon also. The scale looks something like this. Many of you might have had it. There is a roller out here. I have it at home. Normal ruler, there will be a roller. So you can roll it on the book. It gives you a parallel line very easily. And there will be a protector out here and graduations out here. ऐसा. ये खरीद के रखिए छोटा वाला. Use. I think it will be there in our golchas also. Roller scale. Okay. रोलर स्केल से ड्राइंग आसान होता है. तो ये हमने बी ले आया. तो B क्या है? This is the tail of B and this is the head of B. Rule is very simple. Rule says join the head of the other vector with the tail of the preceding vector. अच्छा, अभी कौन सा वेक्टर यहां पे ऐड करेंगे अस्मिता? A को ऐड करना है. A's tail should be added to the head of B. ठीक है ना? तो इसलिए गाना है हेड से टेल मिला. तो ए कहां पे है? ए यहां पे है. दिस इज द हेड ऑफ ए, दिस इज द टेल. तो इसको पैरेलल ट्रांसलेट करेंगे ऐसे ऐसे. दिस इज ए वेक्टर एंड दिस इज ए वेक्टर्स हेड एंड दिस इज द टेल ऑफ ए वेक्टर. डिड यू अंडरस्टैंड? गाना क्या है? हेड से टेल मिला. तो टेल से टेल मत मिला ना, लेकिन हेड से टेल मिला. मिलाया? Then the vector that is drawn from the tail of the first one to the head of the last one gives me the resultant. This is the resultant vector R, and I will write R vector is equal to A vector plus B vector, or we did it as B plus A, so you can write it as B vector plus A vector. Look at R vector. We did it as B plus A. Do you agree? This is the resultant. Means if I had a body which was acted upon, मतलब बॉडी को पांव से खींच रहा था और सर पे मार रहा था, that is same as अपना बॉडी को कहां बनाऊं? अपना बॉडी को सेंटर से सिर्फ आर से खींचने से भी वही इफेक्ट होता. The effect that you will produce by these two forces on this alu is same as the single R force will create on the alu. Have you understood? Now we also should prove, sir, why did you do B plus A? Sir, show A plus B. A plus B. That means I should first draw A. Let us draw A. Let's see whether we get the same resultant or not. Let's draw A. Sir, this is A. This is my A vector. This is the head of A vector. This is the tail. And then bring B vector. Where is B vector? B vector is here. B should be brought in such a manner that the tail of B coincides with the head of A. So this is B vector, B vector's head, B vector's tail. Now join the tail of the first one with the head of the last one. है ना? चलो ज्वाइन करते हैं. This is my R vector. Children, keep your attention on this and this. Don't you think they are parallel? Same resultant you have got? Because in the language of vector, I am allowed to translate it here also, anywhere. तो B को A के साथ जोड़ो या A को B के साथ जोड़ो, की फर्क पैंदा, you're going to get the same result. So here R is equal to A vector plus B vector. Tell me children, have you understood? This will help you in your mathematics chapter. This is head-tail method. However, head-tail method fails to tell me about directions and other things. Okay? Head-tail method fails to tell me about directions and other things. Are we ready now to understand parallelogram method? That is more important. So what do we do in head-tail method? Take the two vectors, take one vector at a time, draw it in a clean place, translate the other vector parallelly such that the head of the second vector, the tail of the second vector merges with the head of the previous vector. Then draw a line. Okay, if we would have had 3-4 vectors, let's see, say for example, if our scenario would have been like this, children. This is F1, F2, F3, F4, F5, F6, F5, F4, F3, F2, F1. So what does the head tail method tell me? Join what beta? Join the tail of the first one to the head of the last one. This is the resultant vector, Fr. इसीलिए मोशन के चैप्टर को देखिए. मोशन में अगर आप वापस आके यही ज्वाइन कर लेते तो आपका नेट रिजल्टेंट क्या होता है? 0 होता है ना. no matter how much you traveled, your net resultant is 0. You don't have any space to draw. Does this clear you now? Displacement, remember displacement, if you are having straight line, straight line, straight line, but end of the day you came from where you started. So what is your net displacement? 0. Because if you take this as vector S1 displacement, S2, S3, S4, and this is S6, if you add S1, S2, S3, S4, S5, S6, you get 0. Is head tail method clear? चलें parallelogram law में आइए. We now go to parallelogram method. Because I have seen a lot of questions coming in graphical method where you have to draw these and then find out. आ जाओ. And grade 11 people learn this once again. आप अभी सीख लो parallelogram law. अच्छा, in the first law what was our song? Head से tail मिला. यहाँ change हो जाएगा. यहाँ होगा tail से tail मिला, not head से tail. Tail से tail मिला. So let's say two vectors. Let's say we have got a vector something like a vector b, and we have some vector something like say vector a. We are supposed to add these two vectors as per parallelogram law. Step number 1. Bring the two vectors in such a way that their tails coincide. Okay, very good. So I take b vector and I bring b vector out here. This is b vector. And I bring now a vector, parallel translation, and draw them in such a way that tail से tail मिला. This is a vector. समझ में आया? Right? Once you have drawn this, they form the adjacent sides of a parallelogram. Are we fine? Complete the imaginary parallelogram. Complete the imaginary parallelogram. So how to complete it? Sir, from here you draw datum, datum, datum. Oh. From here I am drawing datum, 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 datum. And from here I am drawing datum, 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 datum. Is my imaginary parallelogram ready, children? Tell me. Now, join the diagonal from the common merging to the imaginary side. Means something like this. And this would be giving your resultant vector of a plus b. Which means that given a tennis ball which was being pulled from both two sides, look at me. Given a tennis ball which was being pulled by two forces, it is same as the tennis ball being pulled by one red force. यही होता है रिजल्ट. Because as an engineer or as a scientist, मेरे को ये नहीं चाहिए सुबह पराठा कितने का खाया, इडली कितने का खाया. अल्टीमेट खर्चा बोलो सर, अल्टीमेटली आर खर्चा किया मैंने. ठीक है ना? अस्मिता का आइकिया का कप में कॉफी है, आइकिया टर्कोइज कलर, प्रूशियन ब्लू. ठीक है, तू ऐसे मत देख, गर्दन में दर्द होगा. हाँ, ऐसे लटक के कप देख रहा है. Have you understood parallelogram law? So let us apply some parallelogram laws and see whether we are able to draw resultants or not. Then we will see how to calculate the resultant also. In your grade, they will not ask you to calculate. Calculation is formula based that we do in grade 11. If you want the formula, I can give you, but it will not help you. It will only bang in your head. Right? So let's take some example. Let me take, say, an example from book and try to see whether we are able to draw. Okay, so that's a nice 4. So in the book there is an example. इसको थोड़ा सा मिटाओ बेटा. ठीक है? ऐसा एक your drawing should be really good in these things to understand physics. Okay, so we have got two vertical suspension systems, not suspension, support systems. These are the walls. These are my walls. And in any drawing, children, center line is always helps you. Center line. This is what I'm drawing is only a center line, okay? This is center line. Why did you draw the center line? I have a spring from this side, okay, and I have a spring from this side also. Here, right? And once I have these two springs, with these two springs, I have attached a load. I have attached a load. Let's say W is the load. Are you agreeing? दोनों spring have been pulled up. There is a pulley or something out here, and both the springs are in tension. You know what is tension? Tension means both the spring have been elongated. दोनों spring खिंच गया है ऐसे, tension में है अभी. Understood? Both the springs will like to recoil back. So as a result, our, say this is spring S1, S1 will be pulling with the force F1. It wants to go back. And similarly, there will be another tension force on this side, which will be F2 offered by spring S2. Are you understanding? दोनों force उस side में जा रहा है. So finally, we would like to understand where is the this is typically your books problem, okay? And they have said, let's say this is some 1 kg, and this is actually the free body diagram, and this is the W force. W is equal to mg, which is acting downwards. ये नीचे आना चाहता है, ये उधर लेना चाहता है, ये उधर लेना चाहता है. ठीक है, इसका हम वेक्टर ड्राइंग करने की कोशिश करते हैं. The weight is being held up here. ध्रुव पहले इमेजिन करो, पहले ड्राइंग ने पहले इमेजिन करो, ये weight has got a weight mg, धराम से गिरना चाहिए, गिर तो नहीं रहा है. Means don't you think somebody is holding the weight by his head? But actually the weight is suspended like this, one this side, one this side. Right. So let us try to find the resolutions. Okay. Now tell me, children, I will try to separate the two vectors out here. This force F2, I am just drawing separately out here. I have got a system where there is a F2 on this side. I am trying to work out why this weight is out here. This is F2. Agreed? And there is one more force which is on this side, exactly parallel to it, and I am drawing it somewhere here. There is a force F1 out here. This is F1, this is F2. We are supposed to now do what? Find the resultant. Because we feel somebody is holding the weight. Otherwise weight to नीचे चला जाना चाहिए था. So some force should be upwards. Our gut feel says that, and we will be correct. Just see. Now let's draw the resultant of this force. कैसे करेंगे? पहले F1 को ले लेते हैं और clean जगह पे draw करते हैं. Let's say this is F1. This is F1 at a clean place. We'll use parallelogram law. What does parallelogram law tell me? Parallelogram law tells me that join the two tails together. So I bring F2 and exactly draw it here. This is, say, my F2. How many of you have understood? I just parallelly translated F2 को यहाँ से यहाँ उठाया, F1 को यहाँ से यहाँ उठाया. ठीक है? The next step was complete the imaginary parallelogram. So let us complete the parallelogram. Right? This one. So it has gone a little bit on top, children, don't worry. So we will complete the imaginary parallelogram. This is the imaginary parallelogram. Done. Done? Done. And then what does the final step say? Draw. My dimensions are not exactly clean. Draw, join the diagonal from the common place, and the arrow is towards this side. This is the net force that is acting. This is F net, which is acting as the vector sum of F1 plus F2. So let me write it here. I get F net, which is the vector sum of F1 plus F2. Now children, tell me, what is the direction of F net? If you see properly, the direction of F net is something like this. Actually it should have been straight, but I'll not disturb my drawing. This is F net. And what is F net trying to hold? F net is trying to hold and match. It has to exactly match what? W equal to mg. इसीलिए आपका बॉल यहां पे रुका हुआ है. Welcome to mechanics. F net must be exactly equal to W. This was the system of all forces. We brought them into one force. This is called free body diagram in higher classes. The body has been, our body is that particular weight. What is your body? The body has been the weight. In free body diagram, we say strip the body from all the forces, everything, and just see what is the net force. What is the net force now acting on the body? Zero. Zero. इसीलिए तो बॉडी स्टैटिक इक्विलिब्रियम में है, वरना लटको लटको करते रहता था ना. So we will say that F net as a force, or let us not write it as F net because F net लिखने से language खराब हो जाता है. So children, we will write it as FR. Let's say this is FR. F of R is this. So FR is on this side. So we will now say FR is a vector which should be exactly equal and opposite to the W vector. W is weight. Weight is a force, mind you. Weight is a force with which Earth pulls the body towards its center. है ना? ये चीज समझ में आया? FR is exactly opposite to W. That means bring them both towards on the same side. FR plus W, both the forces if we add together, we get a net force of 0. So body is under equilibrium. इसीलिए मेरा weight लटका पड़ा हुआ है, ना नीचे जाता है ना ऊपर रुकता है, क्योंकि नेट फोर्स उस पे 0 है. अगर नेट फोर्स 0 नहीं रहता, अब इसको आप डिस्टर्ब कीजिए. हाउ डू यू डिस्टर्ब इट? जस्ट टेक अ सीजर एंड खच करके इसको कट कर दो, कुछ ना कुछ अलग हो जाएगा. Actually in foreign classes and school na, they've got simulation software where you can in your laptop cancel this force and you can actually see how the ball goes on this side. हमारे में वो सब है नहीं. We are more with set squares and all. But if the basic is good, then everything is good. आपको समझ में? Yes sir.
I have just two questions. Sir, is there more than two vectors and more than?
Then more than two vectors. So right now we have to create one victim. Let us create Ahiri as the victim and let you and me first pull Ahiri. This is Ahiri, you and me are pulling her. Can we find out what is the net pull by us?
Yeah.
You have understood? Now we bring Sahasra and Nidhi also. 4 of us will pull her. So we have to solve it 2 by 2. First you and me, we get a resultant. Then it's just like a badminton match in a society. Then we will make Nidhi and Sahasra's resultant. Their resultant will then fight with our resultant, and finally you will get one resultant. It's like that. This is called the system of superposition of vectors. When more than one vector system is acting on a force, then the net force is found out by taking the effect of each individual force. Yeah, Kirtan, I think your alarm is on.
Sir?
Yes, Kirtan, I could understand.
No.
Oh, all okay, he just got up. So in superposition, this we'll learn in grade 11. We say when a system is acted upon by too many forces or too many vectors, the net vector is found by individually adding the vectors, each vectors. So first we will take, say, me and you, one resultant, Nidhi and Sahasra, one resultant, our resultant and their resultant, one final. That will show how Ahiri's head is being pulled. Final. और ऐसे ही करते हैं. अभी recently did you see US में जो वो बाल्टीमोर का ब्रिज गिर गया था, when the ship went and just hit the bridge and the bridge fell down. So just imagine how many system of forces were there. Ultimately, after the collision, some net force was created, and that must be created in the downward direction. इसीलिए ब्रिज धड़ाम से नीचे गिरा है. तो ये जो हम स्ट्रक्चर्स वगैरह बनाते हैं, आप सोचो, people are and I'll not say something which you should get partial about it, but children, I believe when you study engineering now, the heart of engineering is 3 branches: civil, mechanical, electrical. They are called the core of engineering. When you get over on a flyover every day, the IKEA flyover or any time, do you once also think that you will fall down? When you get down from an aircraft, passengers fasten your seatbelt, we have been touching Hyderabad runway. Do you imagine how much of weight happens on that small piston of that front wala wheel? Yeah, that is called design. आप घर में, which floor do you stay, Ahiri? Which is the floor do you stay? 17th floor. There must be in and around you some floor where there is an infant or a बच्चा. होगा 17. उसका माँ उसको सुलाता है ना रात को, कभी ये डरता है कि धड़ाम से बिल्डिंग गिर जाएगा? So this is the power of designing, and these comes from your core. अभी लोग इतना IT क्रेज ले लेके, IT is an enablement tool. मैं उसको engineering नहीं बोलता हूँ. That is an enablement tool which enables. Earlier I used to do so many drawings. Today I have got a software which helps me understand whether my board fixation has been straight or not. But the carpenter still makes so many vertical bars which are exactly equal to one another. He doesn't know SI system, he doesn't know MKS, he doesn't have anything. You have got laser pointer gun, what not? So if your basic core is good, you will produce good things. And civil, mechanical, electrical, हम लोग बोलते हैं ना civil engineering, one of the pioneer engineering. Imagine a structure like the Opera House in Sydney. कैसे रह रहा है? How many of you all have gone to Chennai? I don't know. Like my past company, L&T, known as for construction, L&T's head office in what you call Chennai is based on 252 quadratic equations. और पिलर के ऊपर बैठा हुआ है पूरा ऑफिस, गिरता तो नहीं है? आप सोचो. Can you imagine that aircraft? Have you sometimes when you board an aircraft, next time see the aircraft's wheel and the piston. वो चीज धाम करके लैंड करता है, लेकिन टूटता नहीं है. What engineering it has got! And imagine the friction the tire is having when it touches that runway. इसलिए हमेशा IT is good, but don't let the core part of engineering die down in you just to embrace IT. First understand core, then everything becomes very interesting. Civil is everything about structure. Mechanical is everything about machinery and structure. In between civil and mechanical, many subjects are common, many papers are common. Like they study strength of materials, we also study. I'm a mechanical engineer, we also study strength of materials. आप जो ब्रिज के ऊपर रोज उठते हो, आपको डर नहीं लगता है ब्रिज अगर टूट गया तो? we think that नहीं टूटेगा ही नहीं. उसका डिजाइनिंग सोचो. And years after years things are remaining intact. Howrah Bridge in Calcutta, made by Britishers, still intact, still it is running. It's not joke. ये जोक नहीं है. ट्रेन, अब रात को ट्रेन में खाना खा के सो जाते हो यार, व्हील्स रेल के ऊपर ठक 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 दौड़ रहा है, ट्रेन गिरता है? नहीं गिरता है. How is it happening? So engineering is engineering, उसमें कोई सवाल नहीं. So have we understood vector resolutions? In your case, children, you will be given vectors which will be now to find out this resultant. इस resultant का जो R होता है ना, FR is given by the modulus, means the value of FR is given by F1 modulus square plus F2 का modulus square plus 2 F1 F2 cos theta. Now you don't know what is cos theta, but just keep it written. Sometime later we will use it. Where theta is the angle between the two vectors. This is theta. F1 F2 cos theta. Right now the problems that they will give you the two vectors which are always maintaining 90 degree. Why they give you 90 degree? Because cos of 90 degree is always is always 0. That means this term gets cancelled out. If it is cos 90, then this term gets cancelled out. So in your book you will see that the resultant is always written as root over f1 square plus f2 square. That is because ये term चला जाता है, cos 90 is 0. लास्ट 1 मिनट लेके छोड़ रहा हूं बच्चा, जस्ट 1 मिनट. दैट मीन्स आपको जो प्रॉब्लम आएगा ना, लुक एट मी once just look at me children. Are they forming the two sides of a, are they forming the two adjacent sides of a parallelogram? Yes. We could have made our imaginary parallelogram here also. यहां भी बना सकते थे और यहां से आपको आपका रिजल्टेंट मिल जाता था, है ना. मैं जो कह रहा हूं, this angle in grade 9 to you will always be given as 90 degree. You won't be given some 60 degree, 30 degree as of now, because you don't know how to calculate cosine. And why are you given 90 degree? Because cos 90 is equal to 0. तो ये वाला टर्म गायब हो जाता है आपकी एक्सप्रेशन से. See, I could have completed to Newton's second law also today. वो ऐसा गधे जैसा फिजिक्स पढ़ के कुछ नहीं होगा. वो हाफ लाइफ देखोगे उसको मजा ही नहीं आएगा. बट नाउ टुडे एटलीस्ट यू नो what is balance force, what is unbalanced force, what is balanced force with equilibrium, what is balanced force with non-equilibrium, what is a torque. You have understood how to represent vectors, how to add vectors, and these will go in a long way if you retain physics for study in higher grades. हाँ, मैं आप ड्रॉप फिजिक्स मतलब आप लिटरेचर लेके पढ़ना चाहते हो तो फिजिक्स ड्रॉप कर ही सकते हो ना, ठीक है. लेकिन ये सब आपको बहुत हेल्प करेगा, राइट. सो वी आर नाउ सेट फॉर न्यूटन्स लॉज ऑफ मोशन विच वी विल स्टार्ट इन आवर नेक्स्ट क्लास. सबको समझ में आया हाउ टू रिजॉल्व वेक्टर्स? गिवन टू वेक्टर्स, you will be using the parallelogram method. Bring the two vectors in such a manner, that you are able to make the two adjacent sides of a parallelogram. Make the imaginary parallelogram, join the diagonal, and the diagonal originates from the joining adjacent to the imaginary side. That is your resultant. That is the resultant. ठीक है. पैराट्रूपर क्यों नीचे जाता है? एक फोर्स इस तरफ, एक फोर्स इस तरफ. So the final force is नीचे की तरफ. Therefore the paratrooper goes down. कपड़ा फाड़ते वक्त देखो ऐसे फाड़ते हैं ना, एक फोर्स इधर, एक फोर्स इधर, नीचे. ठीक है, राइट हो. चलिए